These are some practice problems from the Hibbeler textbook. So one of the challenges with working with coordinate direction angles and spherical coordinates is recognizing them on a problem or recognizing them on a page. Then the second problem is entering them correctly onto your calculator. And so these are actual problems from the Hibbeler textbook that we can just kind of go through and practice identifying these guys. So this is a 75-pound force. It's below the XY plane, and you're given a 45-degree angle from the y-axis to this projection of this force, and you're given a 30-degree angle down from the XY plane. So my question to you is, what is theta, and what is your phi? Because we're going to enter this guy f into our calculator. F is equal to f at theta at phi. So what's theta? So remember, theta is measured from the positive x. And so if this is 45, then theta is equal to 45. What's phi? So remember, sort of spherical coordinate, that's measured from the positive z-axis. And so if you take that down from the positive z, then our phi is equal to 90 plus 30, which is 120. And so into our calculator, we can enter this as 75 angle 45 angle 120 for that guy. So he's in spherical coordinates. This guy here, this is also in spherical coordinates. Now my theta is coming all the way over from here, and my phi is coming down from there. So a 3, 4, 5 triangle, so 3, 4. So an inverse tangent of 3 over 4 inverse tangent 0.75 is 36.9 degrees. 36.9 degrees. So my theta is 90 plus this, which is 126.9 degrees. And so on my calculator, I basically can enter this as 50 angle 126.9 angle 45. Questions on that? And again, you can do the two-step process. You can find the projection of this force and then take the projection of the projection and then the projection of the projection that way too. And so you can do it that way, but I wouldn't, once you know how to do it in your calculator. Here's another example. This is also spherical coordinates. And so now the theta is in the negative direction. So this is theta is equal to minus 60. And then finally, we're looking for phi, and that's equal to 45. So this F vector is equal to 750 angle minus 60 angle 45 here. This guy here, again, these are spherical coordinates as well. You've got an angle measured in the XY plane, which is 30, and you've got a 45 degrees below the XY plane. And so theta is positive 30. And phi, measured from the positive z all the way down to here, is 90 plus 45. So my phi is 90 plus 45, which is 135. And so finally this vector is equal to 800 angle 30 angle 135 to enter into your calculator. This F1 here lies in the YZ plane. You've got 500 pounds at 345. And so basically the Fy is 4/5 of this, which is 400. And the Fz is 3/5 of this, which is 300. So this is a problem where you've got a coordinate direction angles for this guy, and you've got spherical coordinates for this guy. And so if my F2 then, so my F2 vector is equal to 500 times his unit vector. So that's equal to 500. And then unit vector is cosine of 60 to the x, cosine 60x, cosine 45 to the y, and cosine 120 to the z. And so that's equal to 500 times 0.5, 0.707, and cosine of 120 is negative 0.5, negative 0.5. And you can, so that's F2 as a vector. F1 is a little tricky, but again, you've got an angle measured down to the plane, and then you've got to measure an angle in the plane of 45. And so your theta coming all the way from the x, so theta is equal to 90 plus 45, which is 135. And your phi is, if this is 60 degrees up from the plane, phi is 30 degrees. And so finally, F1 is a vector is equal to 300 angle 135 angle 30. And again, you could find the projection and the projection of the projections, but this is way easier on your calculator. This picture here, again, this is spherical coordinates. This F1 is, its projection is in the negative x direction, and it's 50 degrees below the xy plane. So the theta is 90 plus 60. So theta is equal to 150. And phi is equal to 90 plus 50, which is 140. And so F1 as a vector is equal to 60 angle theta, which is 150, angle 140 into your calculator. And finally, this guy is two different vectors. This is coordinate direction angles. You're given angles directly from the x-axis, directly from the y, directly from the z. And this F1 is given in spherical coordinates because you're given an angle or an azimuth in the xy plane, and you're given an angle an elevation from the xy plane to the force. So F2 is a vector is equal to 400 times the unit vector, which is equal to 400 times cosine of alpha, cosine of 120, cosine of beta, which is 45, cosine of gamma, which is 60. And so that's 400. Cosine of 120 is minus 0.5. Cosine of 45 is 0.707. Cosine of 60 is positive 0.5. So that's F2. F1 is a vector, is equal to 250. And so theta is measured from the x to the projection. And so this is, if this is 25, then this is 65. 65 degrees. And then I need phi from z down to here, which is 90 plus 35, which is 125. And that's my F2. I'm sorry, my F1. And so then finally, if you want to get the resultant of these guys, which is basically F1 plus F2, it's super easy to put this into your calculator. So then we're basically going to go, first I'm going to enter this unit vector. So control square bracket, negative 0.5, comma, 0.707, comma, 0.5, and times 400. That gives me this minus 200, 282, 200, okay? And then I'm going to plus that with control square bracket, 250, comma, angle symbol, 65, comma, angle symbol, 125, enter. And if I add these two guys together, I get negative 113.5, 468.4, and 56.6. And those are in newtons. So you can see how straightforward this is. And if you want the unit vector of this guy, then you can actually control C, copy, come to here to your catalog, look for unit vector, control V, paste, enter. You get the unit vector is negative 0.2338, 0.9652, 0.1167, and then the alpha, beta, gamma for this guy are the inverse cosine of these guys, inverse cosine of this guy, and inverse cosine of that guy. So these are just a number of problems from your book, just learning to recognize and practice identifying coordinate direction angles, spherical coordinates, and then dealing with it. And again, using your VAC calculator is so helpful, so powerful. You should get really good at it. And you should get really good at it. To be a great static student, get this calculator, learn how to use it, and you'll fly through statics. You can do it. You can do it.